Welcome to the video lecture series on Six Sigma. And in this video, we will study the basics of Six Sigma control phase and the steps in brief, and also look through some simulated case studies. Without much delay, let's start this journey. I am your instructor Gunjan Subedi, and this is my Lean University, your freedom to professional learning. Before starting the topic, let me remind you that you can access the full course on Six Sigma through the link in the description. Please stay with me till the end of this video for solving the Six Sigma control phase questions and informations regarding free resources.
Now finally we have reached the final phase of the DMAIC cycle, that is, we have reached the control phase. And in this phase we will study how controls are established so that our improvements or gains are sustainable. So it is actually called the control phase because in this particular phase various kinds of control devices, that may be lean devices, or that may be change in the management, or that may be the change in a procedure, or any standardization practices that helps to ensure that our improvements or gains are sustainable. So how do we carry out the control phase? Let's study the steps. The first step is we develop the standards and find the process capability, sigma level, and other calculations. We also establish the sigma levels, DPO, DPMO, and other parameters. Finally, in the control phase, we should specify that we should be running in the particular sigma level, or we should specify that our DPMO or the yield level should be between this and this range. In the improve phase, what we did was we tried to see whether we have made the improvements by using these parameters. That means by using the sigma level, we compared the sigma level, we compared the DPMO or DPO, etc. We try to observe whether we have made any improvements compared to the measured phase value. And in the control phase, we specify that in the future our specifications is this, or say we should be running in the particular type of specification. The second step is we make sure that our new process is well under our control. Now how to do that? For that we use various tools such as monitoring and response plan, control plan and control charts, etc. This is a monitoring plan where we monitor different activities, where we monitor the inputs, process and outputs. We write everything such as targets and how we collect the data, how frequently we are checking, and whom the job is assigned, etc. And in the response plan, if there is anything that is to be acted upon, we write at what point should we try to improve the process, who should respond, how should our reaction plan be like if anything wrong happens with the system. So we also make the response plan along with the monitoring plan. And there is a control plan template also. I'll be providing this template in the particular section. In the control plan, we write what are the parameters in your process that is to be controlled, what is to be measured, what sample size is to be taken to be measured, how should be the specification. The specification talks about both lower specification and higher specification, and the control plan also says what to do if our specification is below or upper than the normal, and how to act, who will act and who will authorize, etc. So the control plan is basically a tabulated form of our plan to control the process. And as I said before, we try to run various types of charts. We try to visually observe whether we have made any types of improvement in the improve phase. Now in this phase, what we do is we set the specification of the lower and the upper point. That means in this particular phase, we set the upper control limit and the lower control limit. So after we set the upper and lower control limit in this phase, if any deviation occurs, that should be wrote as a trigger point. For example, if our upper specification limit is 10 defects per hour, Then if our production process runs and if we find that our process has higher defects or the process yield has higher defects than the 10 number of parts, then the trigger point is 10. And in the response plan, we have to write we will respond to that deviation, and we write how will we respond to that deviation in the reaction plan. So all these charts, the monitoring plan, response plan, and the control plan work side by side along with the control charts. Now after that, we have to document the improved process. So there are various ways to document the process. We already learned about A3 document or the A3 analysis. We already learned about the project charter, and there are other documents as well, such as specifications or standard operating procedure, where we can document the specification of running the process or the way to run the process in this particular phase. So we work with various types of documents such as standard operating procedures, standard work charts, visual displays and controls, 5S checklists, or any form of document that helps us to know the control limits or that helps us to set the control points of the process. Now these are the kinds of the visual displays. Different kinds of visual displays are available for different purposes. For example, on the upper left hand side, we see the visual displays of the white pictures in the red background, which stands for anything related to fire hazards. Similarly, there are other kinds of visual displays as well. So one of the important benefits of using the visual displays is we can let the employees or any other people, or we can warn or we can show them any kinds of cautions in the process easily, because pictorial form of message is more suitable to the eye. Our eye catches it fast. I saw many kinds of visual displays when I worked in the factory premises in Japan, and they have almost every kinds of visual displays for almost every processes. They have visual displays in the stairs, they have visual displays on the elevator, escalator, visual displays on the road, visual displays on the sidewalk, and almost everywhere. And this helped particularly to me in the beginning when I did not know the Japanese language properly. So one of the important benefits of visual displays is you don't have to worry about the language because it is a pictorial representation. We can also use other forms of the standardized documents such as standard work chart, which shows us how should be the process be moving, where there should be the quality, safety, and standard work in progress, how should be the movement, etc. Another is standard production capacity sheet. This is particularly more important and useful in the production premises, although we can change the header topics for service-based businesses too. So here we can write the total operation time of the man and machine, total time for the tool changes, and whether we are taking longer or shorter time than what is the time specified. We'll be learning the standard production capacity sheet in detail in the control phase. Now the next step is we have to train the staffs about the new control limits and changes in the process. So in the control phase, we establish the controls, we establish the specifications, we establish the flow of process, or we establish this is how the process should be working and within these limits. But we have to make sure that every employee is trained about the new control limits, because if not, they will be starting to work under the older process parameters, and if they do so, it will not be fruitful. Our whole Six Sigma project is aimed at making some improvements, so in order to make it fruitful, we have to train the team. Now to do this, we can form different cost training chart. There could be different person allocated for the different roles, and with the help of this cross training chart, we know exactly what the particular person is more trained in, or in which field he should get the training. For example, David is good in marketing because he doesn't have to go for any assisted operation. He can go on his own. He will not have to get assisted by anybody. He's good in sales because he's a trainer in sales, so he is quite good in sales and marketing. But it shows that he's not quite good in the distribution process because part that is said belongs to the untrained person. So this is how we can draw the cross training chart. As I already said, we'll study this one in depth in the section. Next, we finally update the project charter and all the documents such as A3 templates. The tools used are Project Charter and the A3 template. This is an example of the A3 template, and by the end of the control phase, we have to make sure that we have filled all the important section or all the sections of the A3 document. Similarly, the control phase is also the phase where we have to sign off and close, and for that we fill off this sign off phase. We fill off who prepared, who analyzed, and who validated the different steps at the end of the control phase with the signature and date of the project leader and project champion. So this is how we end the Six Sigma project.
Now let me take you to the usual section of the course. Let's run the quiz. The scenario here is Miriam approaches you to helping her draft a Six Sigma implementation plan. She has the following list of activities, or say list of tools. As you have already gone through the phases of Six Sigma, which of the following tools can you use in the Six Sigma control phase? Is it control plan, response plan, project charter, or hypothesis test? Please write your answers in the comment section. I'm eager to check your answers. For more quizzes on Six Sigma control phase and case studies, please do not forget to watch the next video on control phase exams, questions and answers, and videos of other Six Sigma phases also. Also, please do not forget to go through the Six Sigma resources on the description. Thank you so much. Meet you in the next video.